Hi, my name is Amanda. I'm a TA and today I will talk about how to get started with Git. Git is a software that keeps track of changes that you make in a file or a directory. Let's imagine that you are writing a Java program. You write some code and you save it. This is the first version of your project. You make some more changes to it and now you have version 2. Then you make some additional changes and it becomes version 3. Git keeps track of all those versions for you and allows you to move back and forth between all your versions. Git also allows you to compare different versions and to see exactly what changed between each one. Git is referred to as a version control system, since it does just that, controls all your versions of a directory. Git is mainly used by developers to keep track of changes they make to their source code. Git helps them to keep track of changes over time, as they add changes, features, fix bugs, and so on. Without even thinking about it, all of you have been using your own implementation of a version control. For example, when you were writing the first assignment in the project, you probably started out with a file called assignment1, and down the line ended up with files like assignment1, 2.4, draft, or something similar. Google Docs is another example of a simple version control. You can easily see when and by whom a change in a shared document was made. And the most familiar type of version control, Control or Command-C, to undo unwanted changes. Compared to Git, however, all these examples are very primitive. So let's get started. To understand what Git is and how it works, it is helpful to visualize it in 3 different stages. 2 stages that are local, they only exist on your computer, and 1 stage that is online and shared by everyone part of the project. These 3 stages are: the local computer directory, only visible to you. This is the directory you will be working in. It exists locally on your computer. The local master branch, only visible to you. This is where you save all your work that you later want to merge with the rest of the project. The master branch, shared by everyone. This is the official project directory. All code and all files of the master branch is shared by everyone in the project. Your GitLab project is a master branch. When you are satisfied with your commits, you can merge it with the rest of the project, the master branch. To do this, you type git push origin master. Your commits have now been merged. This is where you will encounter how powerful Git version control is. I will talk more about this later in the video. Most of you have probably cloned your GitLab repo already. In this video, I will show another way of initialize a Git repository. Let's begin with creating a new directory where we can work. And now we want to tell Git to keep track of everything that is happening inside this directory. We initialize it to a Git repository. To do this, make sure that you are on the right path in terminal, and then type git init. This directory is now a Git repository, and every single file that you create and every single line of code that you write in this directory, Git can keep track of for you. Even though we just initialized this directory to a Git repo, don't forget that we're still working in the first stage, the local computer directory. Git will only keep track of your work if you explicitly tell it to. Let's continue. Let's edit this file with some text and save it. Currently, this file only exists locally on your computer, and Git does not keep track of it yet. But since we did make the directory a Git repo, we can type git status to see if there are any changes in this directory. As we can see, there actually were some changes. Git is also kind enough to tell us where these changes happened. A new file called just can't get enough was added to the directory. To let Git know that it should keep an eye on this file, we use git add and file name. Now Git knows that these changes should be kept track of. We are still, however, not in the local master branch yet. But didn't we just add a file to Git? Doesn't this mean that it's on the local master branch? No, it just means that we have staged or prepared this file to be committed to the local master branch. Let me show you what I mean. To commit a change in the local master branch, use git commit -m, double quotes, and inside those quotes you write some message. When you make a commit like this, it means that everything that you included in git add will be saved to the local master branch. The message is meant to be a short description of your commit. An example could be writing comments in class XX or adding a getName method. We type git status to see that our local computer directory is now clean and everything is added to the local master branch. You can think of the commits as small Lego pieces that are put together one by one to eventually build a bigger project. Finally, when you have made a couple of commits to your local master branch, you want to push them to the master branch. This means that your changes are good enough to be merged with the rest of the project and to be shared with everyone else. It's important to remember that whatever work you have done in your computer directory will not be merged to master unless you have committed it to your local master branch. This is how you can visualize your local master. Each dot in the chain represents a commit that you made. Or in other words, it represents all different versions of a project that ever existed in its lifetime. With Git, you can navigate back and forth between each version or commit. This allows you to look at or go back to previous versions if you have to. This is an overview of what Git looks like in a bigger scope. In this picture, there are 3 different people working on the same master branch, each of them from their own computer. They all have a chain of commits in their local branch that they have pushed to master. Once they have pushed something to master, all the commits that you pushed becomes available to everyone. All commits have a unique ID assigned to it. This makes it easy to navigate through the history of your project. If someone were to push something that breaks the code, you can reset your project to a previous desired commit. Let's look at the Git workflow and summarize what we learned in this video. You work on a file locally on your computer, and when you are satisfied with a change, you prepare it to be tracked by Git. This is done by git add. This does not mean that it's saved to your local master branch, but you are preparing or staging it to be part of a commit in the near future. Right now, it still only exists in your computer directory. To finally save these changes to your local master branch, type git commit and a message that shortly describes your commit. Your changes have now been saved to the local master branch and can be added to the master branch whenever you are ready. To merge your changes to the top level, the master branch, you perform the git push operation. Your commit is now part of the shared version of the project and can be viewed by all project members. This also means that you can view and access everything that other people pushed as well. If some other person has merged some commits to master, you can get that latest version by pulling it to your local repo. Always pull often to make sure that you are working on the most recent update of the project. And that's all about Git for this time. I hope you learned something in this video and that you will discover what an amazing tool Git is. I'll see you in school and thank you for watching.